We're going to quickly skip over recording motion, so here's the basics. Trolley, ticker tape counter, scissors, graph.
Ready to move on?
Yes. Freefall. Let's start off with a question. Which falls faster, the book or the feather? It's obviously the book, but what happens when you eliminate air resistance?
When you eliminate air resistance, everything falls at the same downwards acceleration of 9.8 meters per second squared. This can change slightly due to variations in the Earth's gravitational field, but the variance is less than 1%. The measurement is called G, and at GCSE level it's usually rounded to 10 meters per second squared.
What are you doing?
I'm throwing a ball in the air to see the minute where it's exactly stationary.
Okay, while she's doing that, I'll explain. Let's assume there is no air resistance. For every second the ball is in the air and rising, it is losing velocity at a rate of 10 meters per second until it reaches 0 meters per second. At this point, the ball is neither rising nor falling. It is, for an instant, stationary. The ball starts to fall to Earth and increases its velocity rate at 10 meters per second. It's accelerating at 10 meters per second squared.
This increase in acceleration will not happen forever. There is something called terminal velocity.
Newton's third law states that for every action there is an equal and opposite reaction. This is evidenced when falling due to gravity.
Let's take a situation where an object, say a free-falling parachutist, falls from a hovering helicopter, like this one.
The person's acceleration will increase until equilibrium is reached with air resistance. This typically happens at around 60 meters per second. In other words, the free faller's velocity will go from 0 to 60 meters per second and then stabilise. At some stage the chute will open. The air resistance will increase substantially and the velocity will reduce and then stabilise. The free faller will then fall to Earth at a lower velocity, land and walk away.
You could ask, well, if the air resistance balances the weight of the free faller, why doesn't the free faller stand still? The answer is quite simple. If the free faller is stationary, there will be no rush of air or air resistance, and the free faller will carry on with their descent to Earth.
And finally, whilst talking about Newton, an object will remain at rest or carry on its path unless an external force is applied to it. We experienced this when we went indoor skydiving a few years ago.
This is Science Rocks.